In this video, we are going to talk about magnetic forces on wire carrying current. Now, when current flows in a wire, a force F is exerted on the wire. The wire is deflected upwards and not towards any of the poles of the magnet. Instead, the force is perpendicular to both the magnetic fields and the current. Now, the direction of that force is determined by what we call the right-hand rule. We are going to talk about that in another video. So, for us to determine the magnitude of the force, this is the magnetic field experience. Now, this wire has length L, and this is the angle that it makes with the magnetic field, and it is carrying current I. Now, the magnitude of the force is directly proportional to the current in the wire and to the length of this wire as well. So because of that, we can say that F is directly proportional to I, L, and B. Then the angle. If we remove this, we can introduce sign of proportionality. We can introduce the constant I, and we'll say L, B, sine theta. The unit of B, magnetic field, is Tesla, or what we call Newton per ampere per meter. If the wire is perpendicular to this field, the force will be maximum, and because of that, the magnetic field will be given as F max over IL. The reason is because since it is perpendicular, the angle is 90 and sine 90 is 1. For example, we say calculate the magnetic force on a 240 meter length of wire stretched between two towers carrying a 150 ampere current. The Earth's magnetic field of 5.0 times 10 raised to power minus 5 Tesla makes an angle of 60 degrees with the wire. Now, one thing we need to know is that F is equal to KILB sine theta. But we must also know that K, the value of K is always 1. So because of that, this can be rewritten as F equal to ILB sine theta. So in this place, here in this question, it says for length L is 240 meters stretched between two towers. Current A, ampere, current I is 150 ampere. Magnetic field B is 5.0 times 10 raised to power minus 5 Tesla. And angle theta is 60 degrees. Having gotten this, we can fix them into this value that F is equal to 150 times 240 times 5.0 times 10 raised to power minus 5 Tesla times 60 sine 60, I beg your pardon, sine 60. So we need to first of all find the value of sine 60, and then we can plug. When you compute everything, you are going to get on this other side, you can get 1.8 sine 60, and then when you sine 60 is about 0.866 if I'm correct. Then when you multiply that, you are going to get 1.56 approximately force Newton.